Hi, everybody. So, yeah, thanks for your patience while we got the technology sorted out. I'm Christophe Pettus. I'm the CEO of PostgreSQL Experts, and we're going to talk about Postgres 15. Postgres 15 is right now in beta. So it's beta 4, I believe. So download it and test it. You can get it through the standard packaging mechanisms or download and build the source if that's how you roll. It's very, very, very helpful at this point to get get field experience with it, especially across large data sets, because there's only so much that the build farm can do to test it, and we do find lots of bugs while it's released. So get it, fire it up in your staging and dev environment, and see what you think of it. So this is just an overview. There's always dozens upon dozens upon dozens of bug fixes and new features in Postgres each new major release. So check the release notes. I'm going to go through what I think of as the highlights, but there's other stuff that we won't have time to touch on. So get the release notes and check it out. We'll be looking at improvements in 5 areas: performance, systems administration, security, logical replication, and SQL enhancements. So at the end of which will be the reveal on why this particular logo for this version of Postgres. Okay, performance improvements. The first one is sorting. The algorithms for sorting in Postgres, when it needs to sort a result set for some reason, either on disk or in memory, have been improved a lot. They vary between 25 and 400% faster than the original ones, and the version 14 edition. And this will be, especially when you're processing any kind of large result set, they're doing the sorts in order to do a merge join, that kind of thing. It'll be a significant improvement. So that's great. There have also been improvements in window function performance, specifically the row number, rank, dense rank, and count when used as window functions. Well, the first 3 really only make sense as window functions, and count when used as a window function. So some very significant performance improvements there. And kind of a small thing, but will be very useful. Previously, if there was a distinct clause in select, it couldn't be parallelized. It would always do it as a single operation rather than split it into parallel workers. That restriction has been removed. Select distinct can now be parallelized. So yay. There's some pretty cool stuff involving the write-ahead log. The first one is that wall can now be compressed by either LZ4 or Z standard. These are significantly improved compression algorithms, and will, especially for full page writes. Sometimes Postgres needs to write the entire page into the write-ahead log, for example, right after a checkpoint. And compressing those can save a lot of space in the wall. And these are much improved compression algorithms. They both compress better and they take less CPU to do so. Which compression algorithm, or whether it compresses or all, can be configured by a parameter, by a guck. The next one, so there has been a third-party tool that we've recommended quite a bit called PG Prefalter. It was originally developed at a hosting provider, at Joanne, excuse me. And the way it worked is, so the problem that it's trying to solve is recovery on a secondary, and the recovery process is what replays the wall on a binary replica when it's receiving changes, is single-threaded. There's one role receiver, there's one recovery process that's grinding through the wall, applying everything. It has to apply all the wall that was generated by however many clients there were on the primary, and so sometimes it can have a lot of trouble keeping up with that. One way to speed that up is that to look ahead in the wall, ahead being things that haven't been applied yet, and tell the IO subsystem to start reading in the pages that it knows it's going to need. So parts of the tables that are indexes or whatever that are coming ahead. This functionality is now built into Postgres. So you can tell it to look ahead in the wall stream. This only applies on a binary replica that's recovering. And prefetch pages, or tell the IO system to prefetch. And this can greatly speed up how the secondary's role application, and especially if you've been in a situation where the secondary just couldn't keep up with the wall volume, this can help a lot. It's configurable whether it happens or all. How far ahead in the wall it looks is configurable. It does take more memory and more. There is a performance impact of looking ahead farther and farther. It uses the POSIX fadvise call. Not every kernel and not every operating system supports that call. Some of them simply don't let you do it. There's no such call. Some of them silently accept the fadvise call, but don't do anything with it. So you will need to be recent Linux kernels all support it. So that's and every most modern file system support it. So you're in good shape there. So there's really no for the default settings, there's really no reason to leave it off. So I would just leave it on, and that way, if there's a sudden burst of wall activity, you're covered. So this is great. It's very useful functionality. Okay, and now let's talk about systems administration. Administration doesn't look right there. Okay, let's first back up. So since the dawn of time, the way Postgres has had functions called PG begin, start backup, PG stop backup, and those were called to bracket a backup operation. It did a few things. It did a checkpoint. It turned on full page writes. It did things like that. They weren't. You could only have one backup running at a time using these. So you would log in, issue begin backup, do your thing, issue stop backup, you're done. There were significant problems with this. One is if the backup stopped for some reason, you were now in kind of an undefined state where you had to go in and force the backup to terminate. You could only do one backup at a time, which for some large systems was a problem. There were also some holes in the backup process that could leave you with an invalid backup, and obviously that's not acceptable. I'm trying to remember which version it was, 9.6, something like that. A new method of starting a backup was introduced called, which is non-exclusive backup. You connect to the server, issue a different form of the start backup call, and that connection then is held open while the backup runs. If that connection drops, the backup is automatically terminated. And you can have any number of these run at the same time. That is the new modern way of doing it. Everybody at this point should have switched over. It's been a long time coming. And now they're finally removing exclusive backup mode. So it'll be gone in 15. It won't work. If you have a backup tool that uses it, you'll get an error when it tries to do this. So if you're using a custom-written backup, all modern, like Barman, PG Backrest, all the tools that you will usually come into contact with that do backups, PG-based backup, of course, already use non-exclusive backup mode. So you don't have to change any of those unless you're using extremely old versions. But you do have to. But if you have a custom tool of some kind that uses these, and there are plenty of those out there, the things that do things like ZFS snapshots and that kind of thing, you'll need to update to use those. Or probably better yet, maybe this is a good time to switch to a pre-written tool by people who are experts at this. So this is a significant change. This is a breaking API change if you happen to use exclusive backup mode. So don't do that anymore. Let's see, moving on. PG-based backup can also compress its base backups using LZ4 and Z standard. So that's nice. The last one is pretty obscure, but it will actually be quite helpful for a lot of backup tools. Archive command is a command, I'm sure everyone's familiar with it. It's a command that's run by Postgres. It's a setting that contains a shell command that is executed every time, every time a wall segment is complete. What it's intended to do is take that wall segment and move it someplace safe, like write it to a different storage volume or upload it somewhere. Every time it runs, it forks a new shell, and that's not cheap. And it's sometimes archive command can slow down the system to the point that it's having trouble keeping up with the wall starts growing. There's now a second new way of handling segment archiving where you write some C and plug it into Postgres, like any extension, and say use this. And Postgres will call will call a function inside that, and it will do the archiving. It might the simplest thing I can think of is it might hard link to someplace else on the disk where there's another process that reads things and parallelizes them and writes them up. Obviously, this is for experts. This is not something most installations will be doing, writing their own C plugins and that kind of thing. But the ultimate benefit of this is it'll be much easier for the archiving to keep up in high volume situations. So, yay. Let's take a moment of silence for the stats collector process, which has been in Postgres a long, long time. There, that was nice. Thank you. When you start up Postgres 15, you'll see that there is no stats collector process anymore. The stats collector was one of the processes that run inside of Postgres. It actually opened a UDP port, and everything else sent stats to it to be collected and written into a temporary stats file, which was then written into the permanent database structure when the system shut down. That's been replaced with a shared memory segment. So there's no stats collector. Everything that needs to write stats uses that shared memory segment with appropriate locking. In effect, this is kind of realizing advice that has been given for a long time, which was to move the stats temp directory onto a RAM disk. This kind of makes it policy inside of Postgres. So the stats collection is much faster, much more reliable since the UDP socket buffer could fill up and start dropping stats. It still has the one important characteristic, which is if the system crashes, doesn't shut down cleanly, the stats collected between the last startup and that crash point are lost because they were kept in memory. So if for some reason you have a monitoring tool that checks for the existence of the stats collector, this will need to be changed. I know of a very small number of places that actually do that. So there's this large class of system parameters that say can only be changed by a super user. Postgres 15 introduces the ability to delegate that to a non-super user on a parameter by parameter basis. You can grant the alter system the ability to do an alter system, which sets those parameters to non-super users, so they're able to change it. The main application for this will be in hosted environments where you don't actually get a real super user account, a real Postgres super user account. This will allow that the hosting provider to delegate that to individual to individual users. Obviously, be careful with this because some of these parameters you can affect DOS do a denial of service on the system by setting them incorrectly. So you really don't want to be giving this to arbitrary users to mess around with a production system. But for the hosted environment where you have a fake super user that you use to manage the database, but you don't get a real Postgres super user, this will be very convenient to allow you to do that stuff. Now the text logs, which previously we had either standard format, the old traditional Postgres format, or CSV format, we have another one, which is JSON format. This is very handy for importing into tools. If for nothing else, JSON is a little more reliable and parsable than CSV in some circumstances. It's not particularly human readable, so you're pretty much committing to use tools there unless you're going to be grepping through large JSON blobs and that kind of thing. So that but for tools that absorb logs and process them, this will be a much nicer format for that. Okay, security improvements. And there are some changes here that will probably become as a surprise. So traditionally in Postgres, you could create a new database, log into that database as a non-super user, and then start creating tables. If you try to do that in 15, you'll get an error. By default, non-super users do not have create privilege on the public schema. Every new database in Postgres has one schema called public, plus the catalog schema, PG catalog. By default, previously everyone got create on that by default, and you had to explicitly revoke it. Is not true anymore. You have to explicitly grant the create permission on the public schema to users that you want to be able to create objects in it. This plugs some very, very significant security holes and is generally an improvement, but will be surprising behavior if you're not prepared for it. Existing databases don't have anything revoked from them, so existing databases will have this. But if you do a new initdb or you create a new database in a Postgres 15 database, it will have this characteristic. You'll have to explicitly grant them. The database owner, even if the database owner is a non-super user, implicitly has create privilege, is granted create privilege on the public schema. So if you're using the database owner, that will still work. Excuse me, you can revoke it from the database owner though. So if you want to do that. So just be prepared for that, because a lot of, they'll create it, it's very common, especially using a migration framework, create a new database and then fire up the migration framework, say, create me a new database to this migration, and now it'll get a bunch of errors unless you do the grant up front. So there's been an addition to views that will be pretty handy. So a view in Postgres by default, well, forever before, but by default now still has the permissions of the creating user. This is very useful because it allows you to create a view that has more permissions than the roles that are using it. So for example, if you have a table with some sensitive columns, you can create a view that masks out those sensitive columns, run a query, and then deny read access to that table from everybody, but create a view that they can use, that other roles can use. They can run queries on the view. They can see only the rows, the columns that you want them to, which is very handy. The problem is that if you aren't thinking through this, you can create a security leak by creating a view that shows more of a table than you wanted other users to see. But since it has the permissions of the view owner, it's exposing that. Postgres functions since ever have had a way of handling this, which is there are two different ways you can write it: security definer, which means it runs as the owner with the privilege of the owner, or security invoker, which means it runs as the privileges of whoever's invoking it. So it doesn't get any extra. You don't pick up any extra privileges by doing that. Views now have the ability to be marked as security invoker, so that it only gets the privileges of the person who runs this, the role that runs this. It's probably a good default for future views, unless you are specifically using a view to mask out columns or do other kinds of data hiding, because that way you're less chance of security, of accidentally opening up a view of data that you didn't mean. Okay, there have been many and some really useful changes in logical replication. Yay, we finally have filters. A publisher could filter the rows that are sent to the subscriber, so it doesn't have to send every row. There's a where clause you can tack on to create publication that says only send rows that pass this Boolean expression. So that's very handy. The publisher can also limit the set of columns that go to the subscriber. So you can limit how many the columns that are sent to the subscriber. It doesn't have to send the entire contents of every row. So that's also nice. You define that as it's a characteristic of the publication. You define it when you create the publication. This has been a feature of PG Logical that in-core replication has lacked for some time. So it's nice that we're getting this. One of the things that everybody bumps into at some point if they use logical replication is a logical replication conflict, which is the logical replication will send over a row, but when the subscriber tries to apply that row, either an update or an insert operation to the subscriber table, the subscribe table, it gets a constraint violation. For example, a duplicate primary key violation. When this happens, replication just stops. And previously, replication kind of just broke at that point. You can now have it, you have some more options now when this happens. I will say the options are a little bit fiddly. They're not quite as nice as one could possibly want. But you can cause the logical replication, instead of just throwing up its hands and quitting, it can stop, and you can tell it, okay, skip over that transaction. You have to do this manually. It's not a setting that says, oh, just skip every conflicting transaction. That doesn't exist yet. And you do have to kind of fiddle with logical sequence numbers, the pointers into the wall stream. So it's not perfect yet, but it is an advancement. Hopefully at some point we'll get like better conflict handling on how all this is going to happen, more like what PG Logical does. Okay, and the last section is enhancements to SQL. The first one is regex. Just to get this out of the way, we have some new regex functions. They are largely more convenient forms of functionality that exists. For example, you can count the number of times a regex is hit, get a Boolean result of whether it matched or not. There are like is exposes the tilde and star tilde operators as a function, and you can use regex substring is kind of a convenience form to just yank the matching string out of the regex. Previously, you had to do a match, which returned an array, and you had to pick the right thing out of the array, and it was just messy. So these are nice. So null. Yeah, null is everyone who thinks they understand null doesn't really understand null, because null has no rules. It's totally rebellious. Previously, if you created an index, like a unique index or a unique constraint, and you allowed null values in it, which you can, all those nulls were considered distinct from each other. So you could insert as many nulls as you wanted, because fundamentally null means unknown value. And are two unknown values the same? Well, we don't know. They're unknown. That behavior is very useful, actually, because it kind of means don't enforce uniqueness on this particular row. But it's not always what you want. You can now declare unique indexes and constraints as that null is a unique value, so it'll only allow one null if you allow nulls at all in the index. So for that circumstance, it could be very useful. The SQL standard actually defines a set of JSON extensions, and we now support its standard constructors for doing these, which are JSON array, JSON array egg, JSON object egg. They largely replicate functionality that already existed in Postgres, but they do have some new nice features. One of the JSON constructor can accept a byte A as input. So if for some reason you have a binary it's still text fundamentally, but if it's Unicode text, you can but represented as a byte A, you can feed it into JSON and get a JSON object out. The JSON array constructor can take a select directly, so you can say JSON array open paren select close paren, and it'll build an array out of the result set of that select, which is a nice compact syntax. So one of the unfortunate things about JSON in the real world is the JSON standard says you can't have an object with the same key twice. However, in the real world, you run into these, and the constructors the constructors will allow you to say how you should handle that. In the case of with unique keys, it returns a JSON, not a JSON B, but a JSON object where the duplicate keys are still there. If you say without unique keys, if you say with unique keys, it'll raise an error and won't let you create the object. So you can at least check for that in one thing. These all return JSON. They don't return JSON B, so you have to cast it to JSON B if that's what you want. So, but they do provide some convenient syntax for this. And now the star of the show. This is probably the biggest single new feature in Postgres 15, which is the merge statement. So merge is finally here. If people have history on Postgres, it was originally going to be in version 11. It actually got committed, and then it got rolled back, and there was some drama surrounding it, and then it went away for a while, but it's back. It's a SQL standard statement. It's in the SQL standard. It allows you to update, insert, or delete one table based on another in a batch operation. We already have insert on conflict, which allows you to take alternative action if there's a conflict when you do an insert statement, but this has a lot more power. So here's an example. This is straight out of the Postgres documentation. The syntax is you say merge into a table that's called the target table, so wines in this case, a target table. You give it an alias, which, like any alias in SQL, then completely hides the name of the table. You can't use wines anymore in the table. You have to use W. And then you have a source table, which is part of the using clause, and this is called wine stock changes. Then you have a join condition. This is like any other join condition. It has to be between those two tables, of course, and it's kind of like, it's effectively an outer join, because from the source table against the a left outer join against the wine table. So against the target table. So in this case, every row in wine stock changes is consulted, and either 1 or 0 rows is returned from wines. So that if a row, each of those rows is called a candidate row, and then it walks through what amounts to a case statement and does the thing that matches. So the first one is where not matched. That is to say, there was no entry in wines that corresponded to the line of stock table. And you can add a Boolean predicate to it. So then, and stock delta is greater than 0, then we do an insert. So the idea is if there wasn't one in wines already, we do, and there's a positive value in the stock level, we create a new stock entry for it. Okay, well that didn't work. Let's say it was matched. Then then we have the option of, well, if it's matched, and if we add these two stock levels together, so these Boolean operations as part of the AND clause can refer to both tables, then we do an update. And if none of those, if it still matched but it didn't pass that Boolean, we delete the row. The intention there is, well, if the stock level is 0, we get rid of the row in the target table. And this will be applied to all the rows in the it will consult every row in the source, applying them one at a time to the target table. So this is pretty cool. This is like, you can do this rather fancy merge operation. You can have any number of these when clauses. Obviously, you can only have one of each matched and not matched that don't have a predicate, because of the Boolean predicate, the part after the and, because once it's hit one or the other of those in the appropriate condition, it's done. There's no farther it can go. So the source can be any table, view, or query. You could use a query there as well. So you could use a foreign table, which is pretty cool. It's like a way of merging out from a foreign database into the target. The triggers run just as normal. The statement trigger runs before and after the entire merge. The row triggers run on each as each row is processed. It runs as a single transaction, so you get all or nothing. There's no way of changing that. Postgres, everything runs. Every statement has its own has at least one transaction. Implies a transaction around it. Postgres extends the SQL standard as do nothing is a possible operation. You can do nothing is technically not required, but you can add some cleaner, but you can make your statement cleaner perhaps by explicitly saying, by the way, if this condition happens, don't do anything. You could restructure it to just fall through, but this is nicer. Postgres also extends the standard as you can have a common table expression, a with clause before the merge, so you can build a virtual table that is then going to be used as the source table. There are some restrictions. The target has to be a real local table. It can't be a foreign table. It can't be an updated view, an updatable view. It has to be a real base, what Postgres calls a base relation. It can be partitioned though. You can be the root of a partition set, so that's nice. The join should match either 0 or 1 rows, target table rows per source table row, but that's not enforced by Postgres. The results, if you get, you have one target table row and or a source table row that matches 5 target table rows, that behavior is essentially undefined. But whatever you're expecting to do, it'll do something else. So just make sure the join works that way. And source by default is unsorted. It won't pick the order in which it applies the rows from the source table. However, if you then write a query if you use a query instead of a table there and sort it, it will apply in that order. The other thing to be aware of is by the time you're done, every row that you've modified in the target table will have a lock on it. And that could be a lot of locks. So if that table is being accessed concurrently from other sessions, that could cause concurrency issues. Okay, and that's 15. There's lots and lots of other stuff. There's fixes, there's small improvements, there's all kinds of things. And so read the release notes. And there is the link to the release notes. So check them out. Lots of other stuff. Okay, and any questions?
Okay, let's see. I don't. Anybody questions? You can either put your hand up or type it into the chat. And I don't see anything in chat. Really? There are no questions? Oh, Quinn.
Someone must have a question about merge.
Quinn has a question. Quinn, go for it.
Hey, well, I'm just reading the JSON log format documentation, but so when parsing CSV logs, one of the problems you run into is that queries are spread out across multiple lines of the log if they contain new lines. Are they just squished together into one field in the JSON
so, yeah.
format?
I don't know if it squishes out, if it minimizes all white space, but it removes new line to
very cool.
Yeah, which is indeed one of the nice things about JSON log, because occasionally everybody has a slightly different idea about what CSV format is, and so sometimes you're running along and then your tool throws up its hands because of something. So that is definitely an advantage JSON format.
Nice, thank you.
Mm-hmm. Okay, next. Questions? Any other questions?
Everybody run out and have fun with merge.
Let's see, we have a comment from Nat saying, thanks for the nice summary. Thank you, Nat. That's great. Let's see, I don't see anything else in chat. And I don't see any raised hands. I think maybe you gave them all the information they needed before they go read the documentation.
Yay. So, yep, it's currently in beta 4, so it's going to be the intention is to release fairly soon. So the more testing, the better. And yeah, it's very exciting new release. Looking forward to it.
Great. Well, thank you so much, Christophe, for taking the time to prepare the presentation and to share it with us. And I love the merge symbol. I think that's great. And some really interesting new features. So again, thank you. Really appreciate your time. I'd like to thank everybody for coming. And just a reminder that we do Pug the second Wednesday of every month. We are looking for speakers, including a speaker for October. So if you have a great idea, drop us a note. We would love to have you. You win, let's see, what else is coming up? PGConf New York City is next week, September 22nd, 23rd. Tickets are still available. If you haven't registered, grab a ticket, go, and we'll see you in New York. For today's presentation, we will send the link by email when the video is ready. It'll also be posted on our social media. You can find us on Twitter at Bay Area Postgres. And I think that's everything. So again, thank you all so much, and we'll see you in October. Bye.
Yes. Bye-bye. Thank you all.
Thank you.
Bye. Thank you, Christophe.